So this video is on radicals, and it's kind of an introduction. A radical is anything that has to do with this check mark looking symbol here. Often you'll hear these called the root, as in like the square root or a cube root or a fourth root. It could be any root based on the little number right here, but this root symbol means radical. It comes from the Latin word radix, actually. It's the same place where we get the word radish, which literally is a root. Also, if you might say somebody like radically changes, they like change in their roots. Radicals are like going back to the root of a number. They undo exponents. They actually kind of are exponents, but we'll get to that later. So when you see a radical, this undoes a squared. So if you had like x squared, but then you square rooted it, you would get back to just x. So if nothing is written up front, it's understood to be a little 2 right here. But we might have other things besides just that square root. For example, we might have a 3, which is called a cube root, or a 4, or a 5, or any number there. This little number right here is called the index, in case you ever hear that. But again, if nothing's written, it's understood to be a 2. It's not a 1. All right, so we're going to talk about a few radical rules today. So these are the 2 we're going to start with. There are others, but these 2 help us to simplify radicals in various ways. With radicals, there's no hard and fast rule for like the steps that you take to solve it. There are just various tools that might help you, and you're going to have to figure out which ones to apply to different problems. I like to think of it as like a toolbox of different tools you might use, you might not, just depending on the problem. These are the first 2 we're going to talk about. We call this the product rule because it's about multiplication. So if you ever multiply 2 radicals together, you can just combine them all into one radical. Same thing with division, that's why it's called the quotient rule. If you're just dividing 2 radicals, you can combine them all together under that same radical symbol. This only works if they have the same index. So for example, if this were a square root and this were a square root, then it would all just become a square root. The index doesn't change as you bring them together or separate it. So here's an example. If I had 10 square root of 10 times the square root of x, I could just make that the square root of 10x. Or if I wanted, I could go the other direction. If I had the square root of 10x, I could split it up into the square root of 10 and the square root of x. Same thing with division. If I have the square root of 10 divided by the square root of 2, since they're both just square roots, I can combine them into one division problem. And you could actually simplify this because now 10 over 2 is 5. So sometimes that helps to simplify. Again, you could go backwards as well. You could split it up and get to something like this. Again, this doesn't work if the index changes. So if that one were a square root and this one was a cube root, you wouldn't be able to combine them. They'd have to stay separate. But if they were both cube roots, then you could combine them. Remember, the index doesn't change when you combine them. So a cube root times another cube root, it doesn't become a 6 or a 9, it just stays cube root. So don't change the index if you're going to combine them or split them apart. Also, this does not work for addition or subtraction. We'll talk about those later on, but this only works for products and quotients, multiplying and dividing. It doesn't work. You can't split up adding, and you can't split up subtracting in this way. So let's go through a few examples. And our goal in simplifying these is not to get a decimal out. Like, you should not be putting this in the calculator. For example, let's do square root of 2 times the square root of 8. Like, yes, you could put that in the calculator and see what it gives you, but you should be able to do these without a calculator. Seems like it might be an irrational number, but watch what happens. I can't really square root 2 and I can't really square root 8 evenly, but when I combine them, since it's multiplication and I use this product rule, 2 times 8 can combine all together under that radical, and 2 times 8 is actually 16. That was pretty helpful because the square root of 16 is just 4, because 4 times 4 gives me 16. So that one turned out to be a whole number. Let's try this one. The square root of 50 divided by the square root of 2. Again, separately, I can't square root them by hand, but if I were to combine them, let's maybe try that. Let's combine this into 50 divided by 2, all under one radical, which is 25, if you divide those. Well, now the square root of 25 is just plain 5. Let's do another one. This time we're going to do a fourth root of 20x squared divided by another fourth root of 2x. So this is not a 4 multiplying in front, this is a little 4 as an index in front of these. Again, separately, I'm not going to be able to do a whole lot with those, so why don't we try combining it into all one big fourth root. Again, the 4s don't combine or anything, it just stays the fourth root. But I can combine all this. I could do 20x squared divided by 2x. We can simplify this a little bit. 20 over 2 is 10, and x squared divided by x is x, and it's still the fourth root. I can't take the fourth root of either of these, so I'm just going to have to be done there. But at least I simplified a little bit. On this one, they're actually already combined under the same radical. Like over here, we started with all separate stuff, but here it's combined. But I don't know what 121 divided by 49 is, and I'm guessing it's not going to come out even. So this one, it might be helpful to actually break it apart into 2 separate radicals. Since it's just division, I can do that with the quotient rule. The reason that was helpful is because I know the square root of 121, it's 11. And I know the square root of 49, it's 7. So the answer is 11 sevenths. And I didn't even need a calculator. Let's do another one like that. Again, these are already together, but I can't do much with that. So maybe instead, let's try to split it apart into the square root of x squared and the square root of 36. Because the square root of x squared is just x, and the square root of 36 is 6. So x over 6. All right, just want to show you one final thing. A problem like this. Again, I warned you about this before, but the putting them together or breaking them apart, that only applies to multiplication and division. It does not apply to addition or subtraction. So it's really tempting to say that this would be the square root of x squared plus the square root of 36. Just break it apart. But you can't do that because of this plus. I'll show you what to do later when you're adding and subtracting radicals, but you can't split it apart if there's a plus or a minus.